Hello, and in this video we're looking at differential equations, but specifically the ones where you can separate the variables in order to solve them. And that's not true of all differential equations, but the first step, those ones you encounter differential equations are usually in this form. So where you've got dy by dx equals some function of x and y, if you can rearrange this so all the y things are on the left and all the x things are on the right, then we can just do two separate integrals. So if we look at this, we can divide both sides by y, and we can multiply both sides by dx and get dy over y equals dx over x. Probably a slightly better way of writing it is 1 over y dy and 1 over x dx. And then we can just say, well, let's integrate that side and integrate that side. And we know that the integral of 1 over y is going to be log y, and this side it's going to be log x, and we'll have our plus c. But of course we don't need to have this written in logs. We could write it in a different way. We could say, if we said that this constant was part of the log, we could say that this was plus log c. It doesn't matter how we define c, it's just adding on a number, and log c is a number as well, in which case we can add these together, and when you add logs together you multiply the variables. So we could say this is log of cx, and then we can just get rid of the logs and say that y is some constant times x, or a coefficient of x. And if you wanted to find out what that c value was, you would have to do it. You'd have to know a coordinate that you could substitute in x and y as per the usual. Okay, same thing on this middle one. We're going to move all the x's to one side and all the y's to the other, which is going to give us very much the same thing. We're going to get dy over y plus 1 equals dx over x minus 1. Divide that bit down so the y's are all on the left and multiply the dx up, and then we're going to integrate both sides again. And just like before, when we integrate this, we're going to get logs. So log of y plus 1 equals log of x minus 1. And we can have the plus c again as the log. So like we had before, we had plus log c, but we can bring that in instead as a times. So log of c times x minus 1. And then we get rid of the logs and just say that y plus 1 equals c x minus 1. And you could rearrange that if you wanted to. And then the third example is exactly the same thing. We're just going to multiply the dx up, and we're going to divide the y term down. So this time we get 1 over e to the minus y dy equals 3x squared dx. Well, of course, e to the minus y, when you've got it as 1 over, well, we can get rid of that and say that's just e to the y because of the negative power. And now we can integrate both sides. And if we integrate e to the y, we just get e to the y. That's kind of the point of e. And on this side, it's just a standard integral of a polynomial. So we're going to increase the power by 1 and divide by the power. So this is x cubed, and then we need plus c on the end as usual. Now again, you could rearrange that, but that's up to you whether you want it. If you want it in the form of y equals, then you're going to have to take logs of both sides, in which case that equals log of x cubed plus c. But that's up to you how you're supposed to present it in the end. So this is a really nifty technique for solving a differential equation if you're lucky enough that your differential equation will separate so that you can get all the x's on one side and all the y's on the other. It's not always the case, and there are situations where you have to have a different method to solve your differential equation, but if you can separate the variables, then it's quite a straightforward way of doing it. If you have any questions or comments, then pop them down below. Otherwise, cheerio.